Hey, trick class, we got another triangle to solve. This time we're given just all three side lengths. We're not given a triangle. They're not drawing the triangle for us. We have to draw it. So I've got a 12, a 20. So let's say that's 20. That's 12. And let's say that this is 16. Okay. So this is A, B is 12, C is 16. Now I drew it obtuse. It may not be obtuse. You know, it's just a triangle to kind of get us started, so we can visualize what we need to do next. Okay, now when we do the law of cosines with the SSS, which if you have an SSS you have to do the law of cosines, we want to start off with the largest angle. So that's capital A. All right, this is capital C, this is capital B. So we want to start off here because if there is an obtuse angle, it has to be angle A because that's the largest side length. So we're going to set up. Alright, so the only thing I don't know here is angle A. So I'm just going to isolate the cosine, get all of that other stuff to the other side. Alright, so when I get to simplify this, when I subtract away this 400 to isolate the cosine, you can see what's going to happen here. 400 goes away from both sides. We're left with 0 times the cosine A. That means the cosine of A has to be 0. So what angle makes cosine equal to 0? Remember, cosine, inverse cosine, is defined between 0 and 180. This is 1 on the unit circle, this is 0, 1, and this is -1, 0. So where is cosine, again the x-coordinate for the angle, equal to 0? It happens right here at 90 degrees. So that means A is a 90-degree angle. This is a right triangle. So obviously that's not to scale. It should look something like that. All right, you do not have to redraw this when you're doing it. I'm redrawing it because I just want you to see the actual visual here. So A is 90 degrees, okay? So now I know that C and B are complementary. All right, so I've got my largest angle. I can solve for either of these. I can solve for the middle one or the smallest one. Again, I solve for the smallest one. That's just me personally. But there's nothing wrong at all with solving for the angle C here. All right, because this is a right triangle, actually you can just use trigonometry. I don't even have to use the law of sines. I can say this is opposite, this is adjacent. I can do tangent. I can do opposite and hypotenuse, which would still be sine, but I'm not using the law of sines. I'm just setting up the sine of B is equal to opposite 12 over hypotenuse 20. So B is the inverse sine of that. All right, inverse sine of 3/5, 36.87. All right, and then remember, angles C and B, because this is a right triangle, angles C and B are complementary. So I can just subtract that number from 90. So 53.13 is angle C. 36.87 was angle B. All right, so there is a side that ended up having a right angle in there. So it allowed us to use just good old right triangle trig to solve for those remaining angles.